Yeah, tell me what you are getting here.
Total valency 49.
49, no. No. See how to do this. So basically you have cyclopentadienyl. So if you see
The
valence
screen is not
electron,
really visible.
yeah, huh? Screen is not visible. Okay, just a
Yes,
minute.
sir.
Yeah, now it's visible, na?
Yes, sir.
So yeah, if you see valence electron, so from 3 cyclopentadienyl, it will be your 3 into
3.
5. Okay, for nickel. Okay, so if you see nickel, you have 10 electrons, so 3 into 10. Okay, and carbonyl. So carbonyl is acting as a terminal or bridging whatever. Okay, because carbonyl has only two
Donate 2
electrons two
electrons.
electrons, right? So whether it is
Yes, sir.
acting as your terminal or bridging doesn't matter, it will donate only two electrons. Okay, two electrons. And what you have to add here, because they have already given you that you have three nickel bond. Okay, three metal bond you have. So that means one bond consists of how many electrons? Two electrons. So if
2
you have
electrons.
three bonds, so that means what? 2 into 3, right? So
Yes, sir.
total value you are getting what? 55.
55.
55,
Yes, sir.
right? So according to 18 electron rule, suppose if it is following your 18 electron rule, you have three nickel center. Okay, so 18 into 3 means what? 54.
54 minus
Hmm.
55.
uh, Not 54 minus 55, it will be your z value should be your plus 1. Okay, so if you release, because in total you have 55 electrons, if it releases one electron, that time it will get your 18 electron. Okay, it follows 18
Okay.
electron rule if it releases one electron. So that is why here it should have plus 1 charge, not minus 1 charge. Okay,
Okay, sir.
so like that you have to find out your z value. Okay, so how many valence? Suppose you are getting 49, so that means you have to do like this: 54 minus 49, like that. Okay, you have to
Okay.
think like that. Yeah, but again, after getting this, after putting this charge, then check it what you are getting. You are getting this, like whether it is following your 18 electron rule or not. If it is following 18 electron rule, then only it is valid, otherwise you have to make it opposite charge. Suppose here if you put minus 1 charge, that time it will become 56, not 54, right? So if you are getting minus, if you are putting here minus 1, so that means you are not getting, so you have to make it plus, then only you will get 54. Okay,
Okay, sir.
so similarly for this example you can try. Okay, suppose you have cyclopentadienyl, osmium, okay, co whole to the power x whole 2. Okay, so here write down, given they have also given what? One osmium bond. Okay, one osmium bond you have. Turn off the mic, okay? Turn. Otherwise, in recording, it will be problematic. Huh? Done. So here they are asking how many CO you are taking. Okay, so first of all find out valence electron. Okay, so cyclopentadienyl will have 5 valence electron. Osmium, okay, sorry, you have whole 2 na, sorry. So if you have whole 2, so you can write down like this: Cp2, osmium 2, okay, and it will be your CO whole 2x. Okay, so now valence electron, it will be like this. So cyclopentadienyl is donating 5 electrons, so it will be into 5. Osmium is donating how many electrons? Osmium
8 electrons, sir.
8 electron, fine. And for this carbonyl you will get 2x, and each carbonyl is donating 2 electrons. Okay, so how many metals you have? 2 electrons, right? You have 2 metals. So first of all check what you are getting. So 10 from here and 16 from here, so 26 plus 4x. Now this value will be equal to what? This 26 plus 4x, this value will be equal to what? This value will be equal to how many metal centers you have? 2 metal centers. So if they follow your 18 electron rule, if both the metal centers is following your 18 electron rule, so it will be 2 into 18. Okay, so basically 4x into 4x is equal to what? This value 10 plus 16, yeah, okay, and sorry,
26.
yeah, and they have given one osmium bond, right? So you will get 2 electrons from there, because they have mentioned one osmium bond, so you will get 2 electrons from there. So ultimately you are getting 28 here, 28 here. So what I am getting? 4x is equal to what? 36 minus 28,
4x is equal to 8.
8. So x is equal to 2. Okay, so how many carbonyls you have? 2 carbonyls you have only.
Yes, sir.
Okay, fine, clear.
Yes, sir.
Okay, okay, so here also they want to know what is the metal atom, and they have mentioned that you have one metal bond. Okay, you have one metal bond, so which metal it is, that they are asking actually. And they have mentioned clearly that this metal is actually your 3D transition element. Okay, the metal is your actually 3D transition element. So which metal it is?
Sir, titanium.
Titanium. So first of all, count down the valence electron, na? So
Yes, sir.
first of all, write down you have hole 2, so that means you will have M2, then you will have C6H6 hole 2, and this carbon monoxide will be hole 4. Okay, so now if you see valence electron, okay, so for metal we do not know which metal atom it is. Okay, so that I am considering as X, so you will have 2X. Benzene, okay, so benzene will donate 6 electrons, so 2 into 6. Carbon monoxide, so that will donate 4 electrons, so 2 into 4. And you have one metal bond, so that will also donate 2 electrons. Okay, so how much we are getting? So 2x plus, okay, 12 plus here 8 and plus 2, so 8 2 10 plus 12, yeah, so 22. So 2x plus 22. So again you are getting an equation. So 2x plus 22, that will be equal to what? How many metal atoms you have?
2.
2. So that means if they follow 18 electron rule, it will be what? 2 into 18,
30.
right? So 2x is equal to what? 14, right? So x is equal to 7. So 7 electrons you will have in your metal center. So which metal it is?
Manganese.
Manganese. Okay, 3d5 4s2. 3d5 4s2. So you will have 7 electrons. Okay,
Yes, sir.
clear? Any doubt?
No doubt, sir.
Okay, fine. Next, write down, this is a separate topic, structure of metal clusters. Okay, structure of metal clusters. Okay, so write down number 1, that count total number of electron. Count total number of electrons. So this is actually known as what? Total number of electron, that is basically known as your TEC, total number of electron. Okay, number 2, write down that count polyhedral electron count. Okay, count polyhedral electron count, which is known as your PEC. So first of all you have to calculate TEC, total electron count. Next you have to count polyhedral electron count, which is your PEC. Okay, and okay, so how to counter this polyhedral electron count? So we have a formula. PEC is equal to what? PEC is equal to TEC minus 12N. Okay, TEC minus 12N, where N is equal to what? N is equal to your total number of metal atoms. Okay, total number of metal atoms. Okay, total number of metal atoms. And the third thing is what? You have to do it like this: PEC divided by 2. Okay, so PEC divided by 2. So these are the steps you have to follow. First of all you have to calculate total number of electron. Second thing, you have to find out PEC value, polyhedral electron count, and PEC is equal to what? TEC minus 12N. N is equal to what? Total number of metal atoms. Now if you are getting PEC, so divided by 2, you are getting your value. Okay, so now whatever the value you are getting here from this PEC by 2, that we will now see. So first of all write down one chart. If you have N minus 1, okay, then it will be your supercloso. If you have N, okay, so it will be your hypercloso. Okay, so this PEC by 2 value what you are getting, that you have to check, because initially you have N, which is your total number of metal atoms. So with respect to your total number of metal atoms, you are getting what? N minus 1 or N. Okay, suppose you are getting n plus 1, okay, one extra value you are getting, so that will be your closure. Okay, if you are getting n plus 2, so that will be what? Nido. Okay, closure nido. Suppose you have n plus 3, so that will be what? Arachno. Okay, arachno. If you have n plus 4, so that will be your hypo. Okay, and if you have n plus 5, so that will be what? Clado. Clado. Okay, so this is the chart you have to remember. Okay, so basically we start from here. If you are getting n plus 1, one value extra, okay, one digit extra you are getting from your total number of metal atoms, so it is becoming closo. 2 extra it will be nido, 3 extra it will be arachno, 4 extra it will be hypo, 5 extra it will be clado. If the total number of atoms are same, then it will be your hypercloso. If it is one less, then it will be your supercloso. Clear?
Yes, sir.
Okay, now let's do some questions. So suppose you have this metal class chart, ruthenium 6, okay, carbon, then you have CO whole 17, okay, so what is this? Okay, so first of all you have to count down total electron count. Okay, total electron count. So ruthenium will have how many electrons? 8 electrons, so 6 into 8. Carbon will have how many electrons? 4 electrons. And carbonyl, you know how many electrons you have? 2. So 2 into 17. If you add 48 plus 4 plus 34, so you are getting 86. Okay, this is your total electron count. Next you have polyhedral electron count. So polyhedral electron count is equal to what? It is equal to your TEC, okay, total electron count, minus 12n. Okay, so this total electron count value is what? 86. Okay, minus 12 into what is the n value you have? How many metal centers you have? 6, right? So 12 into 6, so it will be what? 14. So this is your number 1 step, this is your number 2 step, and now the number 3 step. So that is what? That is you have to find out, yeah, PEC divide by 2. So 14 by 2, so that means you are getting what? 7. So now how to check? So how many metals you have initially? N value is what? N value is 6, and PEC by 2 value what you are getting? 7. So that means what? N plus
Closo.
closo. So that cluster will be your closo type.
Closo.
Okay, closo type. Closo type structure it is. Clear how to do?
Yes, sir, clear.
Okay, now do some examples by you. Okay, so suppose number 2 you have this osmium 5, okay, then you have carbon, okay, and then you have CO whole 15. Okay, so do it, tell me which type it is.
So Nido for n plus 2.
So basically here also total electron count. So for osmium it will be what? 5 into 8. For carbon center it will be 4, and for
15 into
carbonyl
2.
it will be 2 into 15, right? So what you are getting from here?
40 plus 4 plus 30.
76, right?
74.
74, 40 plus 4, 44, 44 plus, okay, 74, right?
Yes, sir.
Yeah, 74, 74, okay. Now PEC. So PEC means what? TEC minus 12N. So how many metals you have? 5. So it will be your 74 minus 60.
60.
So again it is your 14. So this is the number 1, this is number 2, and number 3 will be your what? PEC divided by 2. So what I will get? 14 by 2 is equal to what? 7.
7.
So here n value is what? 5.
5.
And what you are getting? 7 means what? N plus 2. So that will be what? Nido
Nido.
type. Okay. That will be your nido type. Okay.
Yes, sir.
Fine. Now number 3 example. Suppose you have this ruthenium 5 carbon, okay, then you will have CO whole 16. Okay, so yeah, do it.
Sir, n plus 3 is equal to organotype.
Yeah, arachno, right? So for ruthenium it will be again 5 into 8, carbon is your 4 and carbonyl 16. So here you are getting 40 plus 4, 44 plus 32, so it will be your 76. Next you have polyhedral electron count, so it will be TEC minus 12N. So 76 minus 12 into 5, so it will be 16. And third step is what? Third step is your PEC divided by 2, so it will be what? 16 by 2 is equal to what? 8.
8.
Okay, so this is your number 1, this is your number 2, and this is your number 3, right?
Yes, sir.
So now n value is what? N value is your 5 here, but if you see here, what you are getting? 8. So that means what? It is becoming n plus 3, which is your what? Arachnotype,
Organotype.
right? Which is your arachnotype. Fine, clear?
Yes, sir.
Okay. Now next write down that geometry of metal cluster. Okay, so geometry of metal cluster. Okay, so write down here, that is a table, so you have to remember this basically. So TEC, okay, and here write down the geometry. Okay, so suppose your total electron count is 18. Okay, that time the geometry will be mononuclear. Suppose the total electron count, this value is your 48, that time it will be your trigonal planar. Okay, if the total electron count value is 60, so that time it will be your tetrahedral. Okay, if this value is 72, so that time it will be your trigonal bipyramidal. Okay, trigonal bipyramidal, which is your TBP. Okay, if this value is your 74, so that time it will be your square pyramidal. Okay, square pyramidal. If this value is 84, So that time it will be your bicapped tetrahedron. Okay, bicapped tetrahedron. If it is 86, that time it will be your octahedron. Okay, if it is your 90, okay, that time it will be your trigonal prism. If it is your 112, that time it will be your square antiprism. And if it is your 120, that time it will be your cube. Okay, so these are the values you will have. Okay, so if it is 18, then it is a mononuclear. If it is 48, it will be trigonal planar. 60 tetrahedral. 72 TBP, trigonal bipyramidal. 74 it will be square pyramidal. 84 it will be your bicap tetrahedron. Okay, 86 will be your octahedron. 90 will be trigonal prism. 112 square antiprism, and if you have 120 value, then it will be your cube. Okay.
Okay, sir.
So we have a trick to remember this. Okay, so see, first of all it starts from your mononuclear, so write down here M. Okay, now you have 3 times you have T, right? Trigonal planar, tetrahedral, trigonal bipyramidal. So write down MT3. Okay, MT3. Then check what is next. Square pyramidal, so write down S. Then you have bicapped, so it will be B. Then you have octahedral, so it will be O. Trigonal prism, so it will be T. Square antiprism, it will be S. And cube, it will be C. Okay. Right.
Yes, sir.
So this MT3 you just write down like this, no need to change this. Now this is, you can remember single. Okay, B brother. Okay, single brother. O stands for your old. Okay, single brother, old. Okay, single brother, old. T stands for your traffic. Okay, traffic. S for your signal. Okay, so single brother, old traffic signal. Okay, and C stands for your C, you can write down chocolates. So this sentence has no meaning. Okay, but yeah, if you can remember like this, the MT3. Okay, first of all it will start from MT3. So M stands for your mononuclear, and 3T, so basically trigonal planar, tetrahedral, then TBP. Okay, then write down this sentence, that single brother, old traffic signal, chocolates. Okay, so this line has no meaning, but yeah, you will get this, all the geometry you can remember by this trick. Okay.
So these geometries are
Yeah, geometry.
only for total valence electron, like
Total
particular.
electron count. Suppose they have, we will do some example of like that. Okay, so they will give you some compound, and then they will ask you what is the geometry. So that time you have to just check the total electron count. Okay, no need to find out polyhedral electron count, and that's all.
So
Okay.
in case the total valence electron 76, what is the
that
geometry?
time it will not be here.
Okay, sir.
That time you cannot guess. Okay, but yeah, if the total electron count values like lies within this region, okay, if you are getting these values only, then you can predict only. Okay, otherwise we cannot predict. Okay, in
Okay,
books
sir.
also they have not mentioned. Okay, so next write down geometry. So suppose you have this compound RH6 CO16. Okay, try to solve it. RH6 CO16.
86.
So 86 means what?
Octahedron.
Octahedron. Okay, so total electron count will be what? 6 into 9 plus what? 2
16
into
into 2.
16. So you are getting 86. So you can
Total
remember, see here, 86 means what? 86 means
octahedron.
octahedron, right? So it
Yes,
will
sir.
be your octahedral. Okay, number 2, suppose you have this IR4. Okay, CO whole 12. Okay, so yeah, find out this IR4 CO whole 12.
60 tetrahedral.
So here total electron count will be what? 4 into 9 plus 2 into 12. So you are getting 60, which means what? It is your tetrahedral. Okay, now number 3, suppose you have this Fe5 CO whole 15C. Find it out.
Square pyramidal.
Square pyramidal. So
74.
here it will be 5 into 8 plus 2 into 15 plus 4. So 40 plus 30 plus 4, it will be what? 74. And it will be what? Square
Pyramid.
pyramidal. Okay, square pyramidal. And suppose you have this osmium 6. Okay, CO16 and CnBu whole 2. Yeah, find it out.
CNBO, how many electrons it will donate?
Hmm?
CNBO.
That you have to find out, na. CnBu, this is butyl group. Okay, CnBu means it is your butyl group. So if you see, so carbon has 4 electrons and nitrogen is the 3 valency, right? So nitrogen will form 2 bond and 1 bond it will form with your butyl. So nitrogen valence is fulfilled, carbon is forming 2 bonds, so that means it can donate now 2 electrons, right? 2 electrons left, so those 2 electrons it will donate. Clear?
Yes, sir.
So total electron count will be what?
84, sir. By capital tetrahedron.
6 into 8 plus 2 into 16 and plus here these are 2 into 2. So you are getting 84. So that means write down bicapped.
Tetrahedron.
Yeah, bicapped tetrahedron. Bicapped tetrahedron. Okay, or you can write down, this is also known as your like doubly capped tetrahedron. Doubly capped tetrahedron. Okay,
Okay, sir.
fine. So another thing I am just starting. Okay, so Next you will have borans. Okay, so borans means what? Basically the compounds which are forming by your boron and hydrogen. These compounds are only known as your borans. So the compounds which are formed by only boron and hydrogen, okay, these are your borans. And another type of compounds we have, so this is basically known as your carborans. So carborans means what? Carboran means the compounds which are basically formed by your carbon, boron and hydrogen. Okay, carbon, boron, hydrogen, so this is your carborans. If you have only boron and hydrogen, then it will be your borans. Okay, now suppose you have Bn, okay, Hn whole 2 plus, okay, BnHn whole 2 plus, so that will be your supercloso. Suppose you have only Bn, okay, Hn, BnHn, so that time it will become your hypercloso. If you have this Bn, okay, Hn 2 minus, okay, BnHn 2 minus, so that time it becomes your closo. Okay, if you have Bn Hn 4 minus, so that time it will become nido. Okay, if you have Bn Hn 6 minus, okay, so that time it will become your arachno. Okay, if you have Bn Hn 8 minus, so that time it will become your hypo. Okay, and another left, so that is your Bn Hn 10 minus, so that time you will get clado. Now how to remember this thing? So basically how I remember like this, that if you are getting 2 minus, so it will be directly closer. Okay, if you are getting 2 minus, so you are getting closer. Now you just see 2 minus, you just multiply by 2, what you are getting? 4 minus, so 4 minus means it will be nido. Now 2 into 3, it will be 6 minus, so 6 minus will be arachno. 8 minus, so that means you are multiplying 4 by your minus 2, so you are getting hypo. And if you multiply 5 by your with your minus 2, so you are getting 10 minus, which is your clado. Okay, so this is like your in childhood two, like 2 series only. So 2 minus closo, 4 minus nido, 6 minus arachno, 8 minus hypo, 10 minus clado. Now if you are getting only BnHn, okay, neutral, you are getting neutral. Okay, so that time it will be hypercloso. And if you are getting 2 positive, so that is your supercloso. Okay, so 2 minus means you are just multiplying by 1, then you are multiplying by 2. Okay, that means 2 minus into 2, then you are getting here 2 minus into 3. Okay, then you are getting minus 2 into 4. Okay, then here you are getting minus 2 into 5, like that. Clear how to do this? Clear?
Yes, sir.
Fine. So one thing I am showing, so suppose you have this compound, okay, B7 H13. Okay, you have this compound, so how to do this? So B7H13, so first of all you just write down like this. Suppose I am writing like this, B7H7, okay, dot H6. So I am just separating the hydrogen. 13 hydrogen initially we have, I am just writing 7 hydrogen with boron, and other 6 hydrogens I am writing separately. Okay, now suppose this compound is releasing 6 hydrogen. Okay, if this compound releasing 6 hydrogen, so what you are getting? 6H plus, right? If this compound releases 6 protons, it will be what? 6H plus. So that means you are getting B7H7 6 what? Minus
6.
Right, minus 6. So that means B7H7. So that means what? You are getting Bn Hn
H
6
minus 6.
minus, so that will be what?
Arcano.
Arachno. Okay.
Arachno.
Now few examples we have. So suppose you have B6 H12. Okay, B6H12 you have, so that time what you will get?
This one is also arachno.
Arachno, right? So initially you will, after that you will get what? B6
H6
H6 6
minus 6.
minus. Okay, so that will be also your arachno. Now suppose you have some carbon derivative. So suppose you have C2 B4 H7 whole minus. Okay, suppose you have this. Now tell me, this carbon is basically what? Carbon is basically how many electrons you have? 4, right? And boron has 3 electrons, hydrogen has 1 electron. So if I add boron and hydrogen, so I am getting also 4. So basically I can what?
P8.
I can replace the carbon by this BH unit. Okay, I can replace the carbon by this BH unit. So what I will get? So if I replace that, so what I am getting? BH whole 2, then you have B4, okay, H7 minus, and that actually leads to what? So you have 2 boron, so basically you are getting B6, okay, and 2 hydrogen here, 7 hydrogen here, so I am getting H9 and negative charge, B6 H9 minus, right? So ultimately what you are getting? B6 H6. So if it releases 3H plus, so it is becoming what? 4 minus, right?
Nido.
So 4 minus means what? You are getting nido.
Nido.
Okay, how you are getting? So if it releases 3H plus, then only you are getting this B6H6 4 minus. Clear?
That's all clear.
Any doubt?
No, sir.
No, right? Fine. So that's it. Okay. The few examples we have, so that we will discuss tomorrow. Fine.
Okay, sir.
Otherwise, it will be problematic. Tomorrow, I will try to finish out this. Basically, this your isolable analogy and these things. Okay. Then we are done with this portion. After that, we will directly go to metal carbonyl complexes. Okay, metal carbonyl complexes we have then. That is very important actually, because in exam they asking questions from that. Okay.
Okay, sir.
Okay, and you are following the classes, recordings you are watching or not?
Yes, sir. I am watching recording classes.
Okay, fine. And also you just you have to attempt the test also. Okay, so whatever the test I am giving in the group, that you have to attempt. Okay, don't skip the
Okay, sir.
test.
Okay.
Okay.
Sir,
Ah.
Sita Nayana, why are you not attending the
No,
classes?
they are also watching classes. They are basically, Sita is also busy with her because she is doing some part-time job also.
Okay.
And Nayana is also attending some days, but some days she have also some work. Okay, because she is also planning to do PhD. So that's why they are little bit busy nowadays. But they are watching the recording classes.
Okay, sir.
Okay, if you see the views in YouTube, so you can get that how many people are watching. Okay, so don't think that you are like they are not watching, they are watching. Okay.
Okay, sir.
Okay, fine. So any doubt, just let me know. Okay.
Okay, sir. Thank you.
Okay, okay, bye, thank you.